Thanks, Stephen, for getting the recording started. Like I said before, it's nice to see some familiar names and faces from Tuesday, some new names and faces, which is great. I had a little bit of conflict coming in today that everyone was going to be excited to talk about math on Tuesday, and no one would be as excited as I am to talk about science today, although maybe I'm still the most enthusiastic person in this space to talk about science. I'm going to go ahead and share my screen, and we will get started on our first session today, which is on grade appropriate science assignments. Give me 1 second. Okay. Michael, can you give me a thumbs up if you can see my screen? Great, thank you. Okay, so as I've already said, I'm very excited to be here today. My name is Elizabeth, and I am a senior manager at TNTP. If you're not here with us live, if you're not watching this as it's happening, you're watching the recording. And first, want to give a reminder that you need to go back and make sure that you watch the opportunity myth session first. That was the first session, because the content from today's session builds on that session. So we want to make sure you've done that first if you haven't done that already. In our time together today, we're going to talk about how you identify whether or not students have access to grade appropriate science assignments using TNTP's science tool. So when you leave your time together today, you should feel better prepared to think critically about how the work, about whether or not the work that you're putting in front of students is rigorous and grade appropriate or not. And so before we get into the meat of the session, I wanted to spend just a minute talking about why I'm here, learning about who you all are and why you are here. And I thought I would open with this picture, which is from my own teaching journey. This is a picture of my first class of students, of 7th grade science students during my very first year of teaching. And like many new teachers, I felt like I had no idea what I was doing. And I don't think that that is an experience that is unique to science teachers, but I felt like no one knew how to help me. We had a math coach, we had a literacy coach, I had administrators that had tons of teaching experience, but not really anyone in my building whose job it was to help me understand what it meant to be a strong science teacher. And so I spent a lot of time just trying to figure it out, feeling really alone. And I think that experience of having to wade through it and find the stuff and figure it out alone was very impactful for me as an educator. And I think I've spent the past 20 years continuing to redefine what great science instruction means and continuing to figure it out on my own. And because of that, I'm dedicated my career to helping to being that person that I was looking for in my first couple of years as a beginning teacher. I've coached science teachers as an instructional coach and as an assistant principal. I was a director of science for a charter school network. And I really want to help more people clearly understand what great science education looks like so that they don't feel like they're fumbling and wading through figuring that out all on their own. So that's why I'm here today. I would love to know who you are and why you are here today. So I'm going to put these 2 questions, and I'd love to see if you could answer them in the chat. You're going to take a couple seconds to introduce yourself in the chat by telling us where you are joining from today and what your role is when it comes to science education at your school. So you can go ahead and enter your answer, and then please scan through the answers of other folks that are here today. I seem to be having a hard time to find my chat. Katrina, are we getting responses in the chat while I try to click through it? Okay, great. Thank you for doing that. And hopefully you're seeing some folks that have the same experience as you or different experience from you, similar communities, different communities. I think it's important to know that in this training, as I'm sure was math on Tuesday, that folks are coming with some folks are coming with a lot of experience and a lot of passion about science. Some folks are more peripherally related to the content. And so we've got a nice diverse experience set today. I'm going to put these norms back up again, which Krista also shared with you on Tuesday. And I think knowing that folks have such a range of experience, it's helpful to really commit to these norms, knowing that we're coming to this work from different places. You know, we are all here because we want to grow our STEM practices for our students at our school. And so embracing like where you are in your own science journey is really important, and making sure that you get the most out of today's content. And that'll help us all to move ourselves closer to those goals that we have for students in high quality STEM outcomes. Couple quick tech reminders here. Please make sure that you're on mute if you're not, since we are recording this session for others to view later. You can use the chat to ask any questions that you have, and Katrina's going to monitor that for us. You'll definitely want to have a pen or pencil, a piece of paper handy to take notes. And I'm going to share with you a link, or Krista is going to share with us a link in the chat that's got the folder for all the materials for the session. Just like the previous sessions, there'll also be an attendance survey at the end to fill out to make sure that your attendance is recorded for today. If you are able to agree to those norms, you just give me a thumb up, and then we'll dig into some content. Thanks, Olivia. Thanks, Mike. Let's see on my screen. Okay, so here is the link for the session materials. Krista, if you want to go ahead and put the link in the chat, you can access the link either by typing it in directly into your browser, clicking on the link in the chat that Krista's sharing, or scanning this QR code. That's going to take you to a Google Drive folder with the handouts for this session. And everything you need is there. So I'm going to give you like 30 seconds to go ahead and get those before I talk while you're clicking and then you miss something. Here's my chat. I found you. Okay. Here are our goals for our session today. We are going to help, we are going to clarify our understanding of what grade appropriate science instruction, science assignments look like using TNTP's oh my gosh, I'm getting ahead of myself. TNTP's student work tool. We're gonna ground that in our understanding of the Tennessee science standards. And then we're gonna practice rating on content. So if you're here with us on Tuesday for the math sessions, pretty similar in structure, but now we are really focusing in on what makes science unique for instruction, for assignments. Krista also shared this slide with you in the opportunity myth session, and I wanted to revisit before we dig into the meat of the science tool. So this is just a refresher of some of the data from the opportunity myth. In the assignments that were evaluated for the opportunity myth, we found that students were successful on 71% of their assignments, meaning that 71% of the time, students got an 80% or better on the assignment the teacher gave them. However, when we went back and looked at those assignments again and asked, did students demonstrate mastery of the standard on the assignment, we were only able to say yes 17% of the time. And so to me, that gap indicates that we just aren't giving kids enough chances to work on tasks that meet the full demand of the standards. And for science, I think that can be particularly difficult because there appears to be far fewer resources out there to help teachers understand what grade level standards look like on assignments, and far fewer high quality curriculum products that give teachers a strong start. So as a result, teachers are often left on their own to figure out what the standards look like and then to create their own materials. So we need to know then, if we're not going to have the resources to tell us what it looks like, if we're not going to have tons of great curriculum products to get us started, we need to be able to answer this question for ourselves. How do we know if the assignments we're putting in front of kids are grade appropriate or not? And so our tool helps us to do this. This tool, this TNTP student work tool, is linked in the Google Drive folder. If you don't have that one open yet, recommend that you go ahead and click that link in the Google Drive folder to access it. This tool can help us to internalize what a strong assignment looks like in a science classroom. We're going to walk through it together today, but I want to give you a few minutes to look at it on your own first. So, Krista, if you want to just put that link in there one more time in case anyone joined late and needs to access it. If you haven't yet, use that link to open the TNTP Science Student Work Tool, and then take 2 minutes to go ahead and read through it on your own. And you can jot down any notes or questions that you have, and then we'll continue our discussion about the tool in about 90 seconds. Okay, so hopefully at a high level, you begin to notice that the tool is organized into 4 sections: content, practice, relevance, and student performance. And this mirrors the organization of the math tool from Tuesday. We're going to start today with the content section and walk through that in depth. And our purpose here is not to be normed as raters at the end of the session, but to use this as a guide for our own understanding. So we'll start with the content section. Content section has 2 questions that we need to ask ourselves. And the first is, does the assignment focus on 1 or more grade level science standard? And do all the questions and tasks reach the depth of the grade level standard? Now, to answer those questions, we have to have a foundational understanding of the structure and design principles that underlie the Tennessee state standards. Okay, so here's some background information for folks that maybe are newer to the standards or aren't as in-depth as all of our science teachers are, I'm sure, are already. The Tennessee science standards were based off of a report, recommendations from a report by the National Research Council. It is entitled A Framework for K-12 Science Education. These are the 6 guiding principles that were shared in the report. And then 3 of these in particular are going to be more prevalent as we walk through the tool today. And so I'll talk about these 3, and I think all 6 have equal weight. These are the 3 that are going to show up primarily in the assignment tool. So the first is that science standards should focus on core ideas and practices. And this allows us to get away from previous standards that might have been mile wide, inch deep. And instead, we are going deeper with our exploration of concepts. And so that allows time and space to actually practice some science, to do some science and engineering practices. The second principle that I'm highlighting here is the recognition that the standards have to progress over time and give kids sustained opportunities to work through and develop the underlying ideas. By giving kids a sustained opportunity to develop underlying ideas, we're allowing students to appreciate the interconnectedness of some of these core ideas over the course of several years, rather than over the course of several weeks. And then the third principle that I'm highlighting here is that this principle calls out that science is not just a body of knowledge. It is also a set of practices that are used to extend the knowledge and refine that knowledge. So if those principles are true, what does that mean for the way that our standards are constructed? Well, we have to move away from previous iterations of standards that looked a lot like this. When I started teaching, this was for sure the standards, how the standards looked where I was teaching. It was 80% memorization of facts about science and 20% kept separate apart of doing science. And what this leads to is teachers teaching these things separately, when really we know in STEM that these things are practiced interchangeably or intertwined at all times. So our new standards cannot have this separation of facts about science and doing science with given different weights. So the framework, the document called A Framework for K-12 Science Education, puts an emphasis on integrating these 3 components into meaningful learning experiences for kids, so that kids are not just having these experiences by doing science, but that the language of these three ideas are integrated into the language of the standard themselves. And I think this picture itself, the way it's presented here is a little misleading because it looks like we spend some time on practices, some time on core ideas, and sometimes on concepts, but actually they are intertwined and connected to each other. And so you'll often see diagrams like this used to represent the dimensions of the science standards because they are all presented together as one. Okay, so if we've got these concepts, these practices, and these ideas, I want to give you a little bit of a picture of what are the practices, what are the concepts, what are the core ideas. There's a lot of words on this graphic I'm about to show you, but you do not need to memorize them, but it's helpful to know that there are 8 science and engineering practices, and I want to show you those so you can begin to read them and get an idea of what kind of things we're talking about kids need to do in science and engineering. There are 7 cross-cutting concepts, and these are the themes that are prevalent across all of science. And I'm showing you these two first and separately because I think if you are here today as a computer science teacher, as a CTE teacher, as some other STEM, a grade level science teacher, these two things are still incredibly relevant to your instruction. What's here in this third bucket of the disciplinary core ideas might look different. The content and knowledge of your course might look different, but there's still equal opportunity to integrate the practices and the concepts into your instruction. And when you do all 3 of these at once, it's called 3-dimensional science instruction. So you often hear these science standards as 3D standards or 3-dimensional learning. So let's take a look at one of the standards to help us understand what it looks like to have the core ideas, the practices, and the concepts intertwined into one standard. This is a high school biology standard. I'm going to give you 30 seconds to read it to yourself, and then I'll do a little bit more voiceover on the structure. Okay, so what's here in the red box is what students are expected to do to show mastery of the standard. So let's see where we see evidence of the 3 dimensions called out as well. The aligned science and engineering practice is here in the blue box. And you can see that it is engaging in argument from evidence. You can see that that's actually in the language of what's in the red box as well. The second sentence, engage in argument about the designation of viruses as non-living based on these characteristics. That means that ultimately at the end of the time teaching the standards, students should have had the opportunity to do that. That doesn't mean that over the course of the instruction, kids shouldn't do the other things. They should still ask and answer questions. They should still plan out investigations, but this is the one that's closely tied to the language of the standard. Right? And then the cross-cutting concepts in the green box at the top. The one that's called out for this standard is patterns. And again, the word pattern itself shows up in what's in the red box, compare and contrast models, identify patterns. And you also see the language of structure and function. And structure and function is in itself its own cross-cutting concept. Okay? So there's opportunity to work on multiple of these big picture themes within one standard. The kids should be having the opportunity to speak directly to the patterns that they are observing and to the structure and function that they're noticing in the content itself, rather than just memorizing these are the characteristics of life and being asked to repeat those as facts. The disciplinary core here is also here in the bottom in the orange box. It tells you that this is related to the LS in the standard language, standard code itself tells us that this is life science. And then the component idea B lets us know this is part of the bigger idea related to the growth and development of organisms. So if we are looking at tasks, we want to look to see that there's evidence of all 3 of these things here. We want to see that it's on the right core ideas, the kids have opportunity to use the practices, and that they're making connections using the cross-cutting concepts. Okay, that's a mouthful from me. So to summarize, these 3 dimensions of the standards are sometimes also referred to as the shifts. And so you can use, if you're putting these 3 dimensions into practice, you're also implementing the instructional shifts. So I'd like to pause here and just hear some reactions from you. So there's 2 questions here, which you can type your answer into the chat, or I'd love for you to come off mute and share an idea with the whole group of how do these instructional shifts align or differ from how you learn science as a student? And how might this impact teaching and learning? Does it make it easier? Does it make it more difficult? What do you think?
I'll start. I know when I was in school, it seemed like what you said earlier, it was a lot of here's this definition, write down the definitions, answer the questions in the book, then you take a test over it, and that's pretty much it. And so this shift, it really makes it a lot more interactive. Like you said, it's taking conceptual knowledge and being able to use it, understand it, and actually implement it.
Yeah, I think so. I think there's also like a lot of nice overlap to what we heard from Krista on Tuesday, right? Like we're not just memorizing things and doing, like we're actually putting things into practice. And I think about my own like education, like how many times was I taught to memorize a mnemonic to maintaining a set of knowledge, and that's not useful. And we know that's like not actually how folks use knowledge in science in college. It's not how science lab courses run, and it's not how in college, and it's not how career science occurs either. Anyone else want to share an idea? Okay, I'm going to keep us moving forward because we've got a lot to talk about today. Thanks for sharing those reflections, and I see the ones in the chat too. So thank you, Scott and Susan. Okay, so back to the tool. I've grounded ourselves in what the structure and the design of the standards. So now we understand what the point is. And now we begin to talk about how do we evaluate an assignment based on those standards. So we are going to use this assignment to practice with today. This is I'm going to tell you, this is an 8th grade classroom assignment. And I'm going to click away from it in a second. So take 30 seconds to read the directions here in blue. I will come back to it. You don't have to memorize it, but go ahead and familiarize yourself with the directions that are here in blue. Okay, so you see we have got an assignment here that is related to earth and space science. We're going to need to get a lot more specific to figure out if that's grade appropriate or not. There are 2 tools that I would recommend that you use when you're trying to figure out if an assignment reaches the depth of grade level standards. The first is the Tennessee Science Standards, and I really like this reference guide, which I included in the folder for you. It's got this picture of kids in lab coats on the front. So if you open that up from your Google Drive folder that Krista shared in the link, that's there. The other tool that I like to help me understand if an assignment is grade appropriate is this Appendix E Disciplinary Core idea progression. It's also in the folder there for you. It's also linked in the tool itself. So if you've got the tool open, it's linked there and you can click. This appendix comes from the framework for K-12 science education. It's Appendix E, which is helping to clearly spell out what the core ideas look like at different grade bands. So those are the 2 tools. So let's dig into them. Okay, so if you don't have this one open yet, go ahead and open this one with the kids on the front with the lab coats. Our first job is to find the standard that we think is most aligned to the assignment. And so I'd like you to try to give that a shot on your own first. I'm going to put the assignment back up. And I'm going to tell you again that it's from an 8th grade classroom. And then I want to give you some time to try to find which standard you think that it is most closely aligned to. So here's the assignment. And when you think you have an answer, go ahead and put it in the chat. If you think you found it or you have a guess, you can put the code for the standard in the chat. No pressure. It's your first time. It's okay to not have the right one. Great question, Scott. No, you are not restricted to 8th grade standards for finding a grade level standard for the line. You can definitely look at the whole thing. And for time, if you're still looking through the document because you're just getting acquainted with it, or you're not sure because you're stuck between two, I'm gonna narrow our conversation down to 2. Okay, so if you looked for an 8th grade standard, this is the one that was probably the closest. This is an 8th grade science, earth and space science standard. So it's in that domain of earth and space science. You might have picked this one if you saw the word planet in there and you thought it was about planets. This would have been a good one to sort of look at. You look really closely at the language of this standard, though. Maybe this is where some folks are having a hard time. You'll see that this standard is a lot more about gravity and its relationship to objects in the solar system than it is actually about characteristics of the planets, like we saw on that assignment. So we didn't see in this assignment a focus on either the origin of the sun and the planet, or the effect of gravity on keeping those things in orbit, or the effect of gravity on how we experience it on Earth, right, with tides and moon phases. So you might have then also been tempted to select this 3rd grade standard if you're trying to decide between the two. I see some nods. Everyone's afraid to put a 3rd grade standard in the chat, but this 3rd grade standard also is about planets and has some language around categorizing planets based on properties. So I think if we're looking for the closest match, this 3rd grade standard is probably actually our closest match. Now, I think that, when as a science teacher, you think about the arc of your storyline and your lesson. And so we could guess that maybe that task was going to then lead to a conversation about size of objects and gravity, but we didn't see that in the assignment itself. So this assignment does not align with the core ideas of the 8th grade science standard. I also wanted to just quickly highlight this other tool that's linked in there to help you understand if the core ideas are grade level appropriate, which is this matrix of understanding. I just find these documents so fascinating because it tells us for earth and space science, what does that mean for 6th and 8th through 8th graders? So if I wasn't sure and I saw that grade level standard, I said, oh, it says planets, and maybe this is also about planets, so maybe it's related. I could use this disciplinary core idea progression to help me figure that out. So if I look at Earth in the solar system and I go down to 6th through 8th grade, what I see is that it's about the solar system contains many varied objects held together by gravity. Again, gravity did not show up in the task that we looked at. And so because gravity didn't show up in the effect of gravity or the formation of the planets didn't show up in the task that we just looked at, this assignment would get a no for focusing on a grade level standard and a no for reaching the depth of the grade level standard. So that is the first half of looking at content. The second half of looking at content is how this content is positioned within the context of a phenomenon, or students are asked to solve a design problem. And so when we're talking about solve a design problem, we're talking about engineering. So either it's placed within the context of a phenomenon, or the assignment is helping students to solve an engineering problem through design. We need to talk about what a phenomenon is, make sure we have a shared understanding before we ask ourselves, is this actually placed within the context of a phenomenon? So a phenomenon is defined as an observable event that occurs in the universe, and we can use our science knowledge to explain that event or predict something that will happen in the future. Here are some examples on the slide of things that are phenomena and things that are not phenomena. So I'll give you a couple of seconds to read that and see the difference between those examples. So you can see that a phenomenon is not a topic. It's not something that stands alone as is, like the water cycle. We don't see the water cycle as a phenomenon, but a phenomenon is a discrete event that unfolds over time. It's not easily explainable, and it can be puzzling. And because it's puzzling, it's interesting to students. And it can be puzzling because maybe it contradicts what you think will happen, or maybe the scale is so large or so small that you can't wrap your mind around it, or you can't visibly see it. And a phenomenon leads you to want to know more. It leads you to ask more questions, to seek answers to more questions, to want to know why and how something happens. And a strong science assignment will be placed within the context of a phenomenon to use scientific knowledge to help figure out or explain what's causing a phenomenon to occur. So based on that definition, would you say that this assignment requires students to use reasoning to make sense of a phenomenon or solve a design problem? First shot at that, but give me a thumbs up if you say yes, this assignment does give kids an opportunity to make sense of a phenomenon, or a thumbs down if no, it does not. I see like 8 faces on my screen, and they all said thumbs down no, which is correct. This does not give kids an opportunity to apply content through a phenomenon or use reasoning to make sense of one, right? Kids are constructing a model of the solar system based on some information, some facts they are pulling from websites and a YouTube video, and then creating this visual representation. There's no purpose for that, and it's not helping them to understand something that's occurring in the natural world at a deeper level. So here are just 2 examples of phenomena that I never get the plural versus singular correct in my words. I know it, I can write it, but I can't say it. Here are 2 examples of phenomena that would align with the standards in case you're curious. So here's the 2 ways this could have looked. So kids could have explained what a king could have watched a video or read an article about king tides, which is when the tide is the highest that it is in the year because of the alignment of the sun and the moon in the earth. So they could have read an article about king tides and then made some predictions about when a king tide might occur, or explain why there was flooding as a result of a king tide. Kids could also have applied their knowledge of gravity and celestial objects to explain the orbit of Halley's Comet. So why does it come when it does? Why is the orbit predictable but sometimes erratic? Those would have been interesting context to place this content within, and having kids explore those things would have made the assignment more meaningful for kids and allowed them to integrate those 3 dimensions by exploring these real life events. If this is like, if Earth and space science is your jam, it's not mine, and you have other ideas because you love the content, feel free to throw them in the chat, because I would be curious if other phenomena came to mind to you when you saw the standard. So because we said no on grade level standard, no on depth of the standard, and no on phenomenon, this assignment would get a 0, as no opportunity for kids to practice with grade level content. Yeah, no appropriate to effort. It is 0 on content for grade appropriate assignments. Okay, that's our quick and dirty practice together as a group on the content section of the rubric. Now let's try to practice it together, or let me give you an opportunity to apply your learning by practicing it on your own. We are going to practice with this 7th grade assignment. This assignment is kind of blurry and tiny here, so it is also linked in that folder. And if you want to go ahead and get that open that link, you'll be able to see it more clearly. And I'm going to give you about 5 minutes to practice rating this assignment on content. I'm going to send you to breakout groups to do that in small groups of about 4. And Stephen, I don't know if you have that set up, and if not, I can quickly throw folks in a breakout groups while we're beginning to look. But you're going to use this assignment and rate just on content alone, and then we'll come back in about 4 minutes to discuss your evaluation of this assignment.
And Elizabeth, let me know which groups we should create.
Random. Can you send us to random groups of about 4?
Perfect. I will go back and do that in a second.
Okay, so I'm really curious to hear how that went for you, how you ended up rating that assignment. Why don't you just show me a 0, a 1, or a 2 for what you gave this assignment on content? Thanks, Olivia, for being brave. Dog Kimber.
I went 2.
Okay, so this assignment is a 2. Great job. It aligns with 7LS16, which focuses on the relationship between adaptations and the likelihood of survival. We saw that reflected in the data that students analyzed and the questions that they answered as a result of the data. If you had checked the appendix, you would have seen that the core ideas also reflect the right core concepts for this disciplinary core idea at the grade band. The core idea was also placed within the context of a phenomenon, and that was that students were investigating the different shaped beaks of the Galapagos Island, and for that reason, it is a 2. So good work. We will not be exploring this in our time together today, but I want to flag for you that this is 1/3 of the tool. There's a section on practice, and there's a section on relevance. And if you want to use this tool to help you evaluate the strength of your assignments, those sections are really important. This assignment would not get a 2 on both of those sections. So if you want to take a look at the language that's there and think about how that assignment is, written, it can be really helpful to think about the domains of practices and relevance as well. Okay. So that takes us to the end of our time for this session. I'm going to show you the attendance survey code, and I'm going to save the reflection question for our next session because we're going to build on this knowledge when we think about strong instruction. Krista just put the link in the chat. So if you want to click on, please either click on the link or type in or use the QR code to fill out the attendance survey so we have your feedback and we know that you were here. That would be great. I'm going to hang out here and I'm happy to answer any questions about the tool or what we've talked about so far. If you want to take a break, we'll get back started at 2 o'clock with our session on strong science instruction.